Titanium clouds engulf this ultrahot Neptune-like planet. A cosmic mirror of sorts, this planet is the first of its size and location to be discovered with an atmosphere. Astronomers have come across the shiniest planet ever found, a mere 265 light-years from our solar system. But that's hardly its only standout trait. Shrouded by thick metallic clouds, this world's temperature reaches a blistering 3000 degrees Fahrenheit, and it quite likely rains scorching hot drops of titanium. The find, named LTT 9779b, was described in a paper published this month in the journal Astronomy Astrophysics. Nearly 5 times as big as Earth, it's one of the few ultrahot, gaseous exoplanets of this size that scientists have discovered. This opens a new window into understanding these kinds of extreme, Neptune-like planets, maybe some of the rarest planets that exist, said James Jenkins, an astronomer at Diego Portales University in Chile, describing this one as probably having a nasty, harsh, dark environment. Initially detected in 2018 by NASA's Transiting Exoplanet Survey satellite, scientists quickly realized that this planet was an oddball. Usually worlds with short orbital periods are either like hot Jupiters, more than 10 times the size of Earth, or are small rocky orbs whose atmospheres have been stripped away by stellar radiation. But LTT 9779b, which sprints around its star once every 19 hours, is mid-size, making it one of 4 or 5 planets in the so-called Neptune desert, and the only one with an intact atmosphere. Optical observations made with the European Space Agency's CHEOPS space telescope uncovered even more about this mysterious world. Dr. Jenkins and his colleagues studied slight changes in the light arriving to the instrument as the planet slipped behind, then in front of, its host star. Combined with infrared data collected by NASA's Spitzer Space Telescope, the team derived information about the planet's thermal and chemical properties. Their results reveal that the planet reflects a whopping 80% of the light from its sun. That beats Venus, the shiniest neighbor in our own solar system. The researchers also worked out that its clouds are rich in silicates, the minerals that make up glass, and titanium. That these clouds are metallic might be what protects the otherwise endangered atmosphere. Most of the stellar radiation bounces off this material and back into space, rather than penetrating the clouds and blowing them away. It's still a mystery how a planet so hot can even form clouds, but Dr. Jenkins speculates that it might be akin to the way steam condenses in the air during a hot shower. It's fascinating that a planet like this can exist at all, said Nicole Cohen, an astrophysicist at NASA Goddard Space Flight Center who was not involved in the work. This initial result is fantastic, because it's telling us that there's more to the story, she added. Plans to follow up with the Hubble and James Webb Space Telescopes are in motion. Those telescopes will provide better optical data that will be captured at higher energies and throughout the planet's full orbit. Additional observations in the infrared are also lined up for the Webb telescope's second year of science. According to Dr. Cohen, these measurements will sharpen knowledge about how the planet's brightness varies along its orbit and possibly even at different altitudes. Over the next 5 years, Dr. Jenkins and his colleagues will also be hunting for more planets in the same star system, which might uncover clues about how this exotic world formed. But LTT 9779b may just be the benchmark for such ultrahot Neptunes. The more the team learns, the more they realize how rare it really is. It's a super important world, Dr. Jenkins said, adding that the diversity of planets in the cosmos stretches far beyond those found in our own solar system. Hopefully, we'll stumble across another. About 2.73 out of 200 Sun-like stars has a planet with an orbital period shorter than 1 day. An ultra-short period planet 1-2. All of the previously known ultra-short period planets are either hot Jupiters with sizes above 10 Earth radii or apparently rocky planets smaller than 2 r. Such lack of planets of intermediate size, the hot Neptune desert, has been interpreted as the inability of low-mass planets to retain any hydrogen-helium He envelope in the face of strong stellar irradiation. Here we report the discovery of an ultra-short period planet with a radius of 4.6 r and a mass of 29 m, firmly in the hot Neptune desert. Data from the Transiting Exoplanet Survey Satellite 3 revealed transits of the bright Sun-like star LTT 9779 every 0.79 days. The planet's mean density is similar to that of Neptune, and according to thermal evolution models, it has a He-rich envelope constituting 9.02.72.9. Of the total mass, with an equilibrium temperature around 2000 K, it is unclear how this ultrahot Neptune managed to retain such an envelope. Follow-up observations of the planet's atmosphere to better understand its origin and physical nature will be facilitated by the star's brightness, Mag 9.8. NASA's TESS starts collecting planets. The satellite, launched in April, has already identified at least 73 stars that may harbor exoplanets, most of them new to astronomers. Somewhere among these grains of celestial sugar and powder puffs of cloudy light there is a planet, perhaps many planets, perhaps even Earth 2.0, as astronomers sometimes call the object of their dreams, a terrestrial look-alike to our own world, a Goldilocks place not too hot nor too cold, where Darwin's dice might have come up sevens. Perhaps even life. On Monday, astronomers who operate NASA's new planet hunting satellite TESS released what they call the satellite's first light science image. Taken last August, it covers a swath of the southern sky showing stars and constellations and the large and small Magellanic Clouds, which are nearby galaxies in their own right, hanging like extragalactic fruit in nearby space. Within this first patch of sky to be surveyed, TESS, short for Transiting Exoplanet Survey Satellite, has already identified at least 73 stars that might harbor exoplanets, most of them new to astronomers, according to George Ricker, an astrophysicist at the Massachusetts Institute of Technology who leads the project. They all need to be confirmed by other astronomers, Dr. Ricker added. TESS is doing great, all that we could have wished for. He wrote in a mail. Sign up to get reminders for space and astronomy events on your calendar. In an explosion of research over the last 3 decades, spearheaded by NASA's Kepler planet hunting spacecraft, astronomers have concluded that there are billions of planets, including potentially habitable rocky worlds like Earth, in the Milky Way galaxy. The frequent occurrence of such planets means the closest one could be only 10 or 15 light-years from here. It will be TESS's job to sniff out those planets by monitoring the light from stars for periodic dimming or blinking that would indicate that planets are passing in front of them. Its designated prey are those planets close enough for the next generation of giant telescopes in space and on the ground to inspect for more promising signs of habitability or even life. There could be as many as 500 of them within 300 light-years, TESS scientists say. TESS was launched on April 18 from Cape Canaveral aboard a SpaceX Falcon 9 rocket and is now ensconced in a looping orbit of the Earth that takes it all the way out to the Moon and then back close to Earth to dump its data. It has 4 cameras that stare at orange slices of the sky from pole to equator for 27 days at a time. Among the 73 candidates the TESS team announced on Wednesday is a so-called super-Earth. It circles the Sun-like star Pymens at a distance of about 7 million miles every 6.3 days, a distance Dr. Ricker described as quite a bit too toasty to be habitable by the likes of us. The same star was already known to harbor a planet some 10 times as massive as Jupiter with a 6-year orbit. That leaves that star with 2 planets, one too hot and one too cold. Only a day later they unveiled another possible planet, a so-called hot Earth that circles a nearby small dim red dwarf star known as HS 3844 in an incredibly tight orbit only about 1 million miles from its sun. The discovery of a terrestrial planet around a nearby M-dwarf during the first TESS observing sector suggests that the prospects for future discoveries are bright. It is worth remembering that 90% of the sky has not yet been surveyed by either TESS or Kepler, the TESS authors wrote. In other words, Goldilocks is still waiting. Kennedy Space Center, FLA. The search for cosmic real estate is about to begin anew. No earlier than 6:32 p.m. on April 16, in NASA's fractured parlance, a little spacecraft known as the Transiting Exoplanet Survey Satellite or TESS, bristling with cameras and ambition, will ascend on a SpaceX Falcon 9 rocket in a blaze of smoke and fire and take up a lengthy residence between the Moon and the Earth. There it will spend the next 2 years, at least, scanning the sky for alien worlds. Watch NASA attempt to launch the TESS spacecraft on Wednesday at 6:51 p.m. Eastern Time. TESS is the latest effort to try to answer questions that have intrigued humans for millenniums and dominated astronomy for the last 3 decades. Are we alone? Are there other Earths? Evidence of even a single microbe anywhere else in the galaxy would rock science. Not so long ago, astronomers didn't know if there were planets outside our solar system or, if there were, whether they could ever be found. But starting with the 1995 discovery of a planet circling the Sun like star 51 Pegasi, there has been a revolution. NASA's Kepler spacecraft, launched in 2009, discovered